Okay, this is the 22 Tech Active paper that we're looking at. Question 11. Now, question 11 talks about the aerial view of a surface of a dam, 6 metres in length and symmetrically positioned on the Cartesian plane as shown. A dam wall is located along the y-axis. The surrounding edge of the dam can be modelled by the ellipse. We then, for part A, so you need to work out using Simpson's rule with 4 strips, determine the approximate area of the surface of the dam. Now, we know this is a symmetrical shape, and this is our y-axis, our x-axis, apologies, going this way. What we're going to do is we're just going to find the area here, and then of course we can double it, can't we? Because we can use that bit of symmetrical. Now, we know that we need to find W, the width. Now it's 6 long, and we're dividing it into 4 strips. So 1.5 metres is going to be my width. Now, for each of my X, Y, I need to find my Y. So across my strips, I'm going to have 0, 1.5, 3, 4.5 and 6. So I need then, just make up a little table. I find a table just nice and easy to get my values. I need to find all my values. What is the easiest way to find my values? Because I need them all. And now there are optional ways of doing it. What I find is the easiest way. I've got my calculator. I'm just going to go to Options, Calculator, Solven. Now, in my Solven, I'm going to have in brackets 0 take 2 close brackets over 16 plus, I'm going to call, I know it's my y, but I'm going to call it x squared on 9, and that shift equals 1. Close my bracket. Execute, solve, and it gives me 3.1. No, that doesn't sound right. That does not sound right. Oh, I left my squared off. Sorry. So easy to make mistakes here, isn't it? That should have been squared. Execute. Exit. There we go. That sounds better. 2.598. So I'm going to go 2.598. Now I know you could go 2 decimal places. I just like to do the third because I like to be exact. Now that means when I go to do my 1.5 in here, I'm just going to go up and delete the 0 and put in 1.5. Execute, exit, 2.976. Then I'll go up. I'll put in a 3. Exit. 2.9047, and I'll go up, delete 4.5, exit, go up, 2.3418, 2.3418, and then of course my last one is 6. Exit, and it gives me 0. Which makes sense because we know that looking at this, as my curve comes over at 6, it hits the 0. So we've got all our values and we know our width. Once we know our values and we know our width, we can use Simpson's rule. Simpson's rule is on your rule sheet. Now, when we label out for our strips and our points at the end, XO, X1, X2, X3, X4. Because when we use Simpson's rule, it's W over 3, it's the ends. So it'll be the ends, so it'll be 2.598 plus 4 times the odds. The odds are this one and this one. So 4 times 2.976 plus 2.3418 plus 2 times the evens, which is 2 times 2.9047 plus your last end. Okay, so that's just coming off here. My 2 ends, the front and the back, 4 times my odds and 2 times my even. And my width, of course, was 1.5. I should substitute that in, shouldn't I? It's then a case of popping that all in your calculator. So we're going to go to our calculator. It's a case of popping it all in. 1.5 over 3. Open your bracket. Then you've got 2.598 plus 4 times 2.97. What was that? Sorry, I've just got 976 plus the other even was 2.3418. Close my brackets. Plus 2 times 2.9047 plus our last end, which was just a 0. So really a bit pointless, but we'll put it in there. Execute, and we get our area as 14.8398. Okay. Now this is only for half, isn't it? We looked at this. This is only half. So therefore our total area is 2 times 14.8398. So about 29.68 kilometres squared is our unit. Okay, so this was just the area for half, so we just had to double it to get total. Everything is in kilometres. That's part A. They do give you much more room. I was very scrunched in my working out there. Probably you would space it more out when you're doing it for reals. Evaluate the reasonableness of this approximation. How would we think? If we can rearrange our formula, so I'll go back to black pen, y squared over 9 equals 1 take x take 2 squared on 16. So y would be the square root of 9 times 1 take x take 2 squared over 16. I'm trying to arrange it so it's y equal a function of x. Why would I do that? Because then I can use my integral. So if I look at my integral from 0 to 6 of the square root of 9, 1 take x take 2 squared over 16 dx, if you do that on your calculator, you get about 15.16. So then you'd say, okay, total area is 2 times 15.16, gives me 30.32 kilometres squared. So we'd say then that therefore answer is reasonable because only slightly different. There's only a slight difference. We had 29.68 by doing Simpson's rule, so it's an approximation. Using an integral, we end up with 30.32. So only a slight difference, so therefore we could say our answer is reasonable, and that's question 11.